Welcome to Astronomy Daily, your source for the latest news in space and astronomy. I'm Anna.
And I'm Avery. We've got an absolutely packed show for you today, with some really exciting developments happening across the solar system and beyond.
That's right, Avery. NASA's Artemis II mission just reached a major milestone that brings us closer to putting humans back on the moon. We'll update you on the impressive journey their massive rocket just completed.
Plus, we're saying goodbye to a spacecraft that refused to give up. Japan's Akatsuki mission to Venus has officially ended after more than a decade of incredible science, but not before delivering some stunning discoveries.
We've also got a fascinating story about China's FAST telescope, solving a cosmic mystery that's had astronomers scratching their heads for years. Fast radio bursts, anyone?
Speaking of mysteries, there's some concerning news about a Spanish military satellite. And we'll explore what might be the most comprehensive year for space science in recent memory, with missions heading to the Moon, Mars, and beyond.
And finally, astronomers have been taking a closer look at dwarf galaxies, and what they found is changing our understanding of supermassive black holes across the universe.
It's going to be a great show, so let's get into it.
All right, Avery. Let's kick things off with some really exciting news from NASA's Kennedy Space Center in Florida. The Artemis II mission just hit a huge milestone.
This is big, Anna. After nearly 12 hours of careful travel, NASA's Space Launch System rocket and Orion spacecraft finally reached Launch Pad 39B this past Saturday evening.
And when you say careful travel, you really mean it. We're talking about NASA's Crawler Transporter 2 moving at a blazing maximum speed of just 0.82 miles per hour.
Right? I could literally walk faster than that. But when you're moving a massive moon rocket, slow and steady definitely wins the race. The journey from the vehicle assembly building covered about 4 miles.
What I find interesting is that they had to make a planned pause along the way. The team needed to reposition the crew access arm, which is essentially a bridge that will provide the astronauts access to the Orion spacecraft on launch day.
That's such a critical piece of infrastructure. Now that the rocket's at the pad, teams are preparing for what NASA calls a wet dress rehearsal, which is targeted for no later than February 2nd.
Can you explain what that entails for our listeners who might not be familiar?
Absolutely. During the wet dress rehearsal, engineers will load the rocket with its cryogenic propellants, super cold fuel, run through the entire countdown sequence, and then practice safely draining all those propellants from the rocket. It's basically a full mission simulation without actually launching.
And this is absolutely essential before putting a crew on board. NASA wants to make sure every system works perfectly.
Exactly. Now, they've noted that additional wet dress rehearsals might be required to ensure the vehicle is completely ready for flight. And if needed, they may roll the SLS and Orion back to the vehicle assembly building for additional work.
Let's talk about the crew. This is going to be a historic mission.
It really is. The Artemis II mission will send NASA astronauts Reed Wiseman, Victor Glover, and Christina Koch, along with Canadian Space Agency astronaut Jeremy Hansen, on approximately 10-day journey around the moon and back.
And this will be the first crewed lunar mission since Apollo 17 in 1972. We're talking about more than 50 years.
That's incredible when you think about it. And this mission is a crucial stepping stone towards landing humans on the moon's surface again, which will then help us prepare for the ultimate goal, sending astronauts to Mars.
The timeline is really coming together. From rollout to wet dress rehearsal to launch, it's all happening.
And every step brings us closer to seeing humans venture beyond Earth orbit for the first time in over half a century. It's an exciting time for space exploration.
Moving from the moon to our other planetary neighbor, we need to talk about the end of an era at Venus. Japan's Akatsuki mission officially concluded in September 2025 after an absolutely remarkable journey.
This is such a bittersweet story, Anna. Akatsuki, which was operated by JAXA and ISS, was Japan's first fully successful planetary orbiter, and it went through quite an ordeal to get there.
Right, because the mission didn't exactly go according to plan from the start, did it?
Not at all. Akatsuki launched back in 2010 with the goal of studying Venus's atmosphere, but it actually failed to enter Venus orbit on its first attempt due to a main engine malfunction. So the spacecraft ended up drifting around the sun for 5 years.
5 years? That must have been incredibly frustrating for the team, but they didn't give up.
They absolutely didn't. In December 2015, JAXA engineers managed a second attempt using the spacecraft's smaller thrusters, and this time it worked. Akatsuki successfully entered orbit around Venus and became the only operational spacecraft there at the time.
So, what kind of work did it accomplish once it finally got into position?
Well, the spacecraft weighed just over 1,150 pounds and carried 5 imaging instruments plus a 6 radio system. Its orbit was highly elliptical, ranging from about 620 miles at its closest to Venus, all the way out to 223,700 miles at its farthest point.
That's quite a range. I imagine that gave them different perspectives on the planet.
Exactly. It allowed for both wide-angle observations and detailed close-up studies of Venus's thick, toxic cloud layers. And Akatsuki made some really incredible discoveries during its decade of operations.
Like what?
One of the most striking findings was a giant stationary gravity wave, about 6,200 miles long. It's the largest of its kind in the entire solar system.
That's enormous. What causes something like that?
These gravity waves appeared as alternating light and dark bands in the atmosphere, and they're created when air is pushed upward by mountainous terrain on Venus's surface. What's fascinating is that how even the lower surface can influence the upper atmospheric layers, despite the crushing pressure.
Akatsuki also contributed to understanding Venus's superrotation phenomenon, right?
That's right. Superrotation is this bizarre phenomenon where Venus's upper atmosphere moves significantly faster than the planet's surface rotates. Akatsuki provided evidence linking this wind acceleration to vertical momentum transfers through waves and turbulence.
So, how did the mission ultimately end?
In late April 2024, contact with Akatsuki was lost during a period of low-precision attitude control. Basically, the spacecraft's orientation and antenna positioning drifted off target. The transmitter likely kept working, but the radio signal could no longer reach Earth.
And despite months of attempts to reestablish communication, they couldn't get it back?
Unfortunately not. JAXA officially sent the final command to terminate the mission on September 18, 2025, just over 15 years after launch. This ensured no uncontrolled signals would continue broadcasting from the inactive probe.
What a legacy, though. Despite all the setbacks, Akatsuki delivered remarkable science about Venus's atmosphere and proved that you should never count a mission out.
Absolutely. It's a testament to the ingenuity and determination of the team. They turned what could have been a complete failure into a highly successful decade-long mission.
From Venus, let's turn our attention to one of the biggest mysteries in modern astronomy, fast radio bursts. And Avery, Chinese astronomers have just made a breakthrough that's reshaping our understanding of these enigmatic signals.
This is really exciting work, Anna. An international team using China's FAST telescope, that's the 500-meter aperture spherical telescope, also known as the China Sky Eye, has uncovered the first clear evidence that some fast radio burst sources actually originate in binary star systems.
Okay, so for our listeners who might not be familiar, can you explain what fast radio bursts are?
Sure. Fast radio bursts, or FRBs, are these incredibly brief but energetic pulses of radio waves from deep space. We're talking about flashes that last less than 1,000th of a second, but can release more energy than our sun emits in days.
That's mind-boggling. And most of these are one-time events, right?
Exactly. Most FRBs are one-off events, which makes them really hard to study. But a handful repeat, and those give astronomers rare opportunities for long-term observation. That's what made this discovery possible.
So tell us about this particular burst they were studying.
The team, led by Professor Bing Zhang from the University of Hong Kong, focus on a repeating source called FRB 220529A, located about 2.5 billion light-years away. They monitored it for 17 months using FAST, which is the world's most sensitive instrument for detecting these signals.
And for most of that time, it seemed pretty unremarkable.
That's what's so interesting. For 17 months, the signal appeared consistent and ordinary. But then, near the end of 2023, something truly exciting happened that transformed the entire study.
What changed?
They detected what they call an RM flare, a sudden, dramatic change in the rotation measure of the radio waves. The rotation measure increased by more than a factor of 100, then rapidly declined over 2 weeks before returning to its previous level. Think of rotation measure as describing how polarized radio waves twist as they pass through magnetic plasma. A sudden change like this reveals shifts in the environment surrounding the FRB source.
And what does that tell us?
Well, this flare suggested that the FRB's environment was suddenly flooded by highly magnetized plasma, likely ejected by a nearby star. It's consistent with coronal mass ejections, those massive bursts of stellar material that our sun occasionally launches.
So that's the smoking gun for a binary system.
Exactly. By linking this RM flare to plasma activity from a companion star, the team provided the strongest evidence yet that some FRBs arise in binary systems containing a magnetar, which is a neutron star with an extremely strong magnetic field, paired with a regular star like our sun.
This contradicts the long-standing belief that FRBs come solely from isolated magnetars, doesn't it?
It does, and it's a major shift in our understanding. The findings were published in the journal Science and mark a real milestone for astrophysics. The observations were corroborated by data from Australia's Parkes telescope, which reinforces the reliability of these findings.
Do these results fit into any broader theories about FRBs?
Actually, yes. They align with a unified model recently proposed by Professor Zhang and colleagues, suggesting that all FRBs originate from magnetars, but those within binary systems have specific geometries and environments that make them repeat more frequently.
So we're starting to piece together the puzzle of why some FRBs repeat and others don't.
Exactly. And this discovery was only possible because of persevering observations using the world's best telescopes and the tireless work of dedicated research teams. It's astronomy at its finest.
All right, now let's look ahead because 2026 is shaping up to be an absolutely incredible year for space science. Avery, where should we even begin?
There's so much happening, Anna. Let's start with lunar missions because we're seeing a real renaissance in moon exploration. Multiple commercial landers and government missions are on the schedule.
And we learned some valuable lessons from 2025's lunar landing attempts, didn't we?
We certainly did. In early 2025, 3 commercial landers attempted moon landings, but only one, Firefly Aerospace's Blue Ghost, succeeded. That was a major milestone as the first fully successful commercial lunar landing.
Blue Ghost touched down near Mons Latrell in Mare Crisium and operated for several days before shutting down during the lunar night.
Right, and Firefly isn't resting on their laurels. They're planning Blue Ghost Mission 2 for November 2026, launching aboard of Falcon 9. This mission will carry some really interesting payloads, including NASA's Lucy Night experiment.
That's the Lunar Surface Electromagnetic Experiment at night. And it's particularly exciting because it'll become the first operational radio telescope on the moon, operating through the lunar night.
Also flying on that mission is the United Arab Emirates Rashid Rover 2. But what makes this launch even more interesting is that it'll debut Firefly's Elytra Dark Space Tug, which will boost Blue Ghost to the moon and insert ESA's Lunar Pathfinder communication satellite into lunar orbit.
There are other commercial missions planned too, right?
Absolutely. Intuitive Machines is planning its IM-3 mission in the second half of the year with another Nova C lander. And Blue Origin will attempt its first lunar landing with the Blue Moon Mark 1 Pathfinder mission, testing systems for future crewed missions.
What about the Griffin lander?
Astrobotics Griffin lander is scheduled for July 2026, and it'll carry Astrolab's FLIP rover, a prototype for their larger FLEX rover being pitched for NASA's Artemis program.
And China's getting in on the action too.
They are. Chang'e 7 is planned to launch this year and attempt a landing on the rim of Shackleton Crater near the South Pole. It's a comprehensive mission with an orbiter, lander, rover, and even a small hopping probe.
Let's shift to Mars. What's happening there?
Well, 2026 marks another Mars transfer window, so we'll see new missions heading to the Red Planet. NASA's twin ESCAPADE satellites, called Blue and Gold, actually launched in November 2025 and are waiting at the Sun-Earth Lagrange Point 2 until the transfer window opens in November.
What will they study?
They'll investigate how the solar wind has been stripping away at Mars's atmosphere over time. And Japan's MMX mission, the Martian Moon's Exploration mission, will also launch during this window to study Phobos and Deimos, and even attempt to collect a sample from Phobos.
There's also the ongoing situation with NASA's MAVEN satellite, isn't there?
Unfortunately, yes. MAVEN lost contact in early December when it failed to check in after passing behind Mars. A small fragment of telemetry suggests the spacecraft might be rotating and its orbit may have changed. NASA had to pause recovery efforts during the Mars solar conjunction, but they plan to start trying again over the weekend. No word yet on how that's going, but fingers are crossed.
Indeed, fingers crossed for MAVEN. Now, what about space telescopes? We've got some major launches coming up.
3 new space telescopes are launching in 2026. First up is ESA's SMILE mission in April aboard a Vega C rocket. It'll study Earth's magnetosphere interacting with solar wind using soft X-ray and ultraviolet observations.
Then we have the Nancy Grace Roman Space Telescope in October.
That's the big one. Roman will launch on a Falcon 9 and features a 288-megapixel camera that'll perform sky surveys with Hubble-quality resolution, but producing images nearly 200 times larger. Construction was completed in November and it's currently in final testing.
And ESA's Plato mission rounds out the year.
Exactly. Plato launches in December aboard an Ariane 6-2 and will search for Earth-like exoplanets in their star's habitable zones. It'll study up to 1 million stars.
There are also some exciting arrivals this year, right?
Yes. ESA's Hera mission arrives at the Didymos binary asteroid system in November, a month ahead of schedule thanks to excellent spacecraft performance. It'll study the crater left by NASA's DART impact.
And don't forget Bepi Colombo.
Right. The joint ESA-JAXA mission enters Mercury orbit on November 6th. After an 8-year journey, it'll deploy 2 orbiters that begin science operations in early 2027.
This really is going to be an incredible year for space science.
Without a doubt. From the Moon to Mars, from nearby asteroids to distant galaxies, 2026 promises discoveries that will advance our understanding of the cosmos.
Now, we need to talk about a concerning development in Earth orbit. Spain's HISDAT company has confirmed that one of their military communication satellites has sustained what they're calling non-recoverable damage.
This is a significant loss, Anna. We're talking about the SpainSat NG-2 satellite, which was struck by what's being described as a space particle. And despite the relatively small size of this particle, the damage is total.
Let's give our listeners some context. This satellite was brand new, wasn't it?
Very new. It launched aboard a SpaceX Falcon 9 just this past October 2025. SpainSat NG-2 was one of a pair of satellites built by Airbus to provide secure communications for Spain's armed forces.
So what exactly happened?
On January 16th, HISDAT released details explaining that while the space particle was estimated to be only millimeters in size and weighing just a few grams, its extremely high velocity combined with the location of the impact caused catastrophic, non-recoverable damage.
That really highlights the danger of space debris and micrometeorites, doesn't it?
Absolutely. Even something tiny can be devastating when it's traveling at orbital velocities. The company did note that because a satellite is in a highly eccentric orbit, it doesn't pose any risk or interference to existing or future space missions.
What are the financial implications?
Well, HISDAT says the satellite was fully insured against this type of incident, so there won't be any direct economic damage to the company. However, here's the thing. While the insurance covers the loss, a claim this large will almost certainly drive up insurance premiums for future satellites.
How much are we talking about?
The total SpainSat NG program cost is around 2 billion euros, according to Spain's official foreign investment promotion agency. So this single satellite claim is likely in the hundreds of millions of euros.
That's going to have ripple effects across the insurance market.
It will. And there's another concern, the replacement timeline. Airbus secured the contract to build the first two SpainSat NG satellites back in May 2019, and the first one launched in January 2025. That's more than 5 years from contract to launch.
So if we're looking at a similar timeline for SpainSat NG3, we might not see a replacement until around 2030.
That's the concern. In fact, HISDAT has already initiated a request for quotation for the replacement satellite. In the meantime, they'll continue providing secure communications for Spain's armed forces using SpainSat NG1 and the original SpainSat satellite.
Wait, the original SpainSat from 2006?
Exactly. That satellite launched aboard an Ariane 5 in 2006 with a 15-year design life, and here we are almost 20 years later still relying on it. That's actually a testament to good engineering and design.
But surely it can't be operating at full capacity after all this time.
You'd expect some degradation, yes. It's remarkable that it's still functional, but this incident really underscores the vulnerability of our space assets and the importance of having redundancy.
This also raises questions about space debris tracking and mitigation, doesn't it?
Absolutely. If a particle just millimeters in size can cause total loss of a satellite worth hundreds of millions of euros, we really need to think seriously about the growing debris problem in Earth orbit and around it.
For our final story, let's venture into the distant universe to talk about some fascinating new research on dwarf galaxies and the black holes at their centers. Avery, this is challenging some long-held assumptions.
It really is, Anna. Astronomers from the Harvard and Smithsonian Center for Astrophysics and the University of North Carolina at Chapel Hill presented what they're calling the most comprehensive census of active galactic nuclei in dwarf galaxies to date.
Now, for listeners who might need a refresher, can you explain what an active galactic nucleus is?
Sure. Active galactic nuclei, or AGN, sometimes called quasars, are the incredibly bright core regions of galaxies. They're so luminous that they can temporarily outshine all the stars in the entire galaxy combined.
And that's because of the supermassive black holes at the center.
Exactly. These supermassive black holes accelerate infalling gas and dust and their accretion disks to near the speed of light, producing intense radiation across the electromagnetic spectrum. Everything from visible light and infrared to microwaves and X-rays.
For decades, we've known that many massive galaxies have supermassive black holes at their centers, and we assumed the same was true for dwarf galaxies, right?
That was the assumption, but scientists have since learned that many dwarf galaxies actually don't have these central black holes. That's why this new census was so important.
So what did they do?
The team reassessed over 8,000 nearby galaxies for signs of active black hole activity. They grouped these galaxies by mass and analyzed the latest optical, infrared, and X-ray observations to detect even the faintest signs of AGN activity.
And what did they find?
Previous surveys generally found about 10 AGNs per 1,000 dwarf galaxies. That's just 1%. But this new census yielded values of about 20 to 50 per 1,000, or 2 to 5%.
So they're finding AGNs are 2 to 5 times more common than we thought?
In dwarf galaxies, yes. Now, this is still significantly less than what we observe in medium-sized galaxies at 16 to 27%, or large galaxies at 20 to 48%. But it's a substantial increase from previous estimates.
What's causing this discrepancy with earlier surveys?
A big part of it was suppressing the glare from star formation, which had been obscuring emissions from accreting black holes. The team developed better detection methods to cut through that glare.
So what does this tell us about how black holes relate to galaxy mass?
Well, the results suggest that AGN frequency is mass-dependent and increases sharply among galaxies with mass similar to our Milky Way. As lead author Magda Polymera explained, there's an intense jump in AGN activity between dwarf galaxies and mid-sized galaxies.
That's a significant finding. What might explain it?
It could indicate a fundamental shift in the galaxies themselves as they grow, or it might mean we're still not catching everything in the smaller galaxies and need even better detection methods. Either way, it's an important clue.
How does this relate to galaxy formation?
Well, as co-author Professor Sheila Canapan pointed out, we believe the Milky Way formed from many smaller galaxies that merged together. So the massive black holes in those dwarf galaxies should have merged to form the Milky Way's supermassive black hole.
So understanding these dwarf galaxy black holes helps us understand our own galaxy's history.
Exactly. These results are essential to test models of black hole origins and their role in shaping galaxies over cosmic time. Are there still uncertainties in this census? Yes, there's still a margin of uncertainty where fainter accreting black holes are involved, so these percentages are approximate. Future observations with more sensitive instruments will likely refine these numbers.
But this gives astronomers a much clearer picture than we had before.
Absolutely. It provides the clearest picture yet of how likely galaxies of different sizes are to host active black holes. And it demonstrates how cutting through the glare of star formation can reveal what's really happening at the centers of nearby galaxies.
And the team is releasing their data for other researchers to verify and expand on.
That's right. They're making their processed measurements available so other astronomers can confirm and build on these results. That's good science in action.
Well, that brings us to the end of another packed episode of Astronomy Daily. From the Artemis II rocket reaching the launch pad to new discoveries about black holes in dwarf galaxies, it's been quite a journey through the cosmos today.
It really has, Anna. We covered everything from the moon to Venus to distant galaxies. And every story reminds us just how active and exciting space exploration and astronomy are right now.
Before we go, a quick reminder that you can find more space and astronomy news on our website at astronomydaily.io. We've got detailed articles, images, and lots more content for space enthusiasts.
And if you enjoyed today's episode, please subscribe to Astronomy Daily wherever you get your podcasts. We're here every day bringing you the latest news from across the universe.
Thanks so much for listening, everyone. I'm Anna.
And I'm Avery. Keep looking up, and we'll see you next time on Astronomy Daily.
Clear skies.